see some people in the audience that already know CUE. I've been here at this conference a bunch of times explaining CUE, but don't worry, for those of you who don't know, I'll be introducing or refreshing CUE a little bit. But today I want to talk about a central registry that we're releasing for CUE. So that's basically bringing package management to the configuration world. And this is slightly different than it works for software. So this is one thing we're going to explain, like how did it come about, what are some of the ideas that went in, and what's the result. So a little bit about us. So I am the creator of CUE. CUE was inspired by, strangely enough, natural language processing, which the grammars of which are remarkably similar to cloud configuration. And then also in Borg. I'm also a co-creator of Borg. Also the predecessor of Borg, which was one of the first declarative configuration systems within Google at least. And then I was on the Go team for 10 years, which is also quite influential in CUE, as you might see. So Roger will give a demo halfway down the presentation, so I'll leave him to introduce him at that moment. So I'll start a little bit with a little bit of history and background to give you a bit of an insight of what I'm talking about from some experience at Google. So as many of you might know, Google uses a monorepo. So monorepos are great. You know, like if you make any change that breaks people, you'll immediately know, right? Like there's no sort of delayed dependencies that pop up. There's a lot of benefits that you get from a monorepo. However, this is on the software side. It doesn't solve all problems in general, right? Like monorepos are not perfect. They're preferable, I think, if you can, but you cannot always use it. But more importantly, one big problem from a monorepo, you can check in the latest version or a new version for some backend, for example, but as you check something in a monorepo, that doesn't mean that automatically you're also updating live services, right? So maybe some people have that, but this is not how it works at Google anyway. So what can happen if you then push a new version or a new API or whatever for a new backend, but you haven't launched it yet? You can have another front end, let's say, that uses that backend that now might think there is a newer version, right, which actually is not launched yet. So you have a discrepancy there. So monorepo doesn't help you prevent that at all. So what is a common solution? It's one of many solutions, but it's a solution that's typically used is to use protobufs, right? The idea is there, so you never reinterpret fields. So like once you say this field or this number is reserved for a certain functionality, you never change that, never reuse. And you make basically services allow graceful degradation, right? So you make sure that if they receive a field or some instruction that they don't know what to do with, they just drop it and you program defensively. So there's a lot of debate whether this is a good thing to do or not, but it's an approach. It works, and this is almost like editor wars, right? Like there's quite strong opinions in either direction, but nobody's right or wrong there. But this is a solution. So what we see here, there is this discrepancy between the software and the configuration world, right? And you can say that the API sort of form a bridge between that. If you're lucky to have an API, right? But that's one of the advantages that protobufs give. So you see, even in the cloud google.com, they refer to that. So one of the flaws of infrastructure as code, right? That is often the code doesn't have a contract, so you hide a lot of the contract, what's in the intent, what the software is supposed to do. So one thing that we do with CUE is that we really want to focus on what is the API, right? What are the contracts? So why do we care again? So another thing I did some research into outages. And you see that in many companies actually, including Google, like more than 50% of the outages are configuration related. And the interesting thing is there's a wild variety of what that means and what kind of outages you have. You have like simple, more complex ones, but in many of these cases, if you just shift left, right, if the information to prevent that outage is actually available, it's just like scattered around, and people don't use that information at lunchtime to detect that something will fail. So this is one of the goals here. So like a little refresher of CUE. So I think this was 2 years ago I gave this presentation, but really the point of the presentation was to show that configuration is everywhere. It's not just your configuration file, but also if you have like Go code, for example, or Java or whatever, where you have flags, that's configuration, right? You might have an API definition that we consider configuration. You can have a policy like Rego, we consider that configuration too, right? Like Terraform. Even the database schema you can see, you can argue is configuration. So won't talk about why this is and why this is important and how that helps you. Viewing it this way helps you prevent outages, but I'll refer to that talk. So as you could see, we have many aspects of configuration that operate at different levels. So you have types, APIs, policy, validation, templates. And you could say they're sort of in a hierarchy, right, from less to more specific. That's quite an important property of CUE. So here you see this in practice, right? So at the top we have a schema. This is very much like you would see in Go or a programming language, where you have like a type of a schema. At the bottom you have data. That's really JSON with syntactic sugar. And in the middle you have, for example, so something in between a municipality and a specific city. You can say we can have a large capital where we don't know the name. We say population, we define it to be at least 3 million, and we say it must be a capital, right? So this is really, you can see there's a continuum from what you can specify in configuration. So another really important aspect of CUE is that it's composable. So normally in engineering, if you're building things together, you have like smaller components, you build larger components, so you have this natural layering. So in configuration, that's often not there. You have like a legal department that puts constraints on things. You have SRE that says, okay, these and these deployments need to be monitored in this certain way. So, and all of these requirements come in from different angles, and there's no natural layering, it's cross-cutting. So CUE basically is defined as from a mathematical term, as a lattice, so it basically allows you to combine things in arbitrary order and you'll get the same result. Right, so that's a very important property, and it allows you to combine things dynamically, but more importantly, if you look at this, I can say, for example, I have some teams that define deployments, for example, for a Kubernetes setup, and I can have then separate constraints where I can say all the deployments need to conform to this schema. I can just define that somewhere else and push that out, right? And that get automatically mixed in with the rest of the configuration. So there's no, in that case, then no need to import it or whatever in separate files. You can just push it out. So CUE, because it has such a well-defined model for what configuration is and data and all these things, we have a lot of converters for other API definitions, data, YAML, TOML, all these things. So CUE is also used a lot as an interoperability tool. So here you see some uses of CUE. So people use it for open API generation, declarative scripting. You can make composable workflows. So policy checking, validation, some people just use it as guardrailing. So you take your millions, whatever lines of JSON, you define this validation layer on top of it, and then everything works well. If you then get comfortable with it, you can say, okay, my validation rules really are templates, and then you can ask CUE to rewrite it and make it all smaller and stuff like that. So there's a lot of tooling around it, lots of different uses, and people find uses that we never anticipated, which is kind of fun to see. So, so package management for software. So just to recap that a little bit, if you ask ChatGPT what is package management, you don't really get a single answer. It gives you a whole bunch of things that are good about it or what its purpose is. So making it easy to distribute, reproducibility, discoverability. So all of these are sort of aspects of a central package management system. So there are some examples on the left. So Rust, you have cargo. Go, you have the Go proxy. So some aspects of it. So there is dependency resolution, right? Like if you have many dependencies, you have different versions. Like which versions do you pick? That's an important aspect. You have to download the components, but also the publishing aspect. is an important thing, and also, of course, provenance and security. So one thing that you need to have to be able to do this is semantic versioning, or any kind of versioning. So semantic versioning is what we ended up using. It's not great. None of the versioning systems are really great, but it's people are used to it, right? And it's good enough. So that's why we're using it. So one aspect of it is you have major, minor, and patch versions. For those of you who don't know. So if you have major versions are basically breaking changes. So that's when you really have an API change that's not backwards compatible. All the other ones are backwards compatible changes. So that can include bug fixes, which has a very specific meaning for APIs, which I'll come back to later. So another one is dependency resolution. So this is, in the Go team, we had very long debates about it. So many languages use set solvers. Go does not use minimum version selection. So minimum version selection, for those of you who don't know, it's like instead of trying to get to the furthest version, you get the least version that satisfies all the constraints, which gives you a lot of stability. It's a much simpler algorithm, actually. And that basically means that if you change one thing, you get the minimal changes and very predictable changes, so you get very reproducible results. So how do we translate this to configuration? So first of all, what does this even mean? I give you a small example in CUE. So this is a tiny bit of CUE on the left. It has some imports and then two schemas that are used within the code. So this CUE can already do that. You can have like local packages that you can import like this. But really with a central registry, these are distributed, right? And we can actually have people publish packages that, as you would expect from a package manager. So this is really what we're getting at. So what is the status quo? If you, for example, look at JSON schema, so there's many repositories for JSON schema, but they don't really have like a good guidelines for versioning. There's no dependency resolution, so it's not really a package manager per se. And that basically means that there's no standards. People might, it's all HTTP based, right? Like people can change the underlying schema. There's no guarantee. So that basically results in very poor reproducibility. So that's one of the problems we want to solve. So then to note, there's some big differences between versioning in configuration and software. So what you see is that in configuration sometimes, because there are so many big changes that you would argue are backwards incompatible, so you see that in some applications people always increment the major version or the equivalent of it. Whereas others say like, no, we always increment minor because even if it breaks, we don't really care, and minor is really what we want to. We always want to force people to go to the latest version. There's a big difference between data and schema, so clearly data is almost impossible to have any kind of sensible say about backwards compatibility. You can say it's at least the API that it represents is compatible, but the data itself doesn't mean much. But what we still aim to do is to have a unified approach for the entire configuration spectrum. So the way we do that is to really focus on the API, right, and the schema. So we can say data might be compatible if the schema is compatible, but really it's the API where we can make good claims over backwards compatibility. And this now gets a little bit back to the protobufs, right? So the rules are basically a generalization of what we do for protobufs. So you're allowed to introduce new fields. If there's constraints on fields, like in policy, they can be relaxed, but not further constrained, right, for backwards compatibility. Another really important aspect of this is that, so the source of truth is really the service itself. It's not the API, right? So you can imagine if a server says, like I only accept up to a value of 5 for this field, and the API says it's 10, you can release a new version of that server, but if you want the API to really catch errors, right, you have to change the API, not the server. The server you cannot change. So we should consider the service as the source of truth. Which basically means that if we allow for bug fixes in API, that means we should allow for what you could consider backwards incompatible changes in the API, right? But they're really bug fixes. So the idea is to get the API to converge on what is reality. So CUE use, we picked MVS, minimum version selection, as the basis for our dependency resolution. So there are some small changes with respect to Go. So we have allow an implicit major version. So we have a little bit more structure in how major versions are represented. This is partly necessary because you have applications in configuration where you bump up the major version all the time. So we wanted to have a bit more structure there. So the CUE registry is OCI based. And you can also map it on your local OCI instance. So there's basically a bunch of tooling around it, like generating documentation that you can build on top of or put on top of your OCI, but we are not restricting it to a single place. So we also have, Roger has been working on putting a lot of curated schemas in it. So we get them, for example, from JSON schema, sources. So we see, people using it for schema, but also workflows, composable workflows. Yes, I'll hand it over to Roger to make it a bit more concrete.
Maybe
okay, yeah.
Hey, so I'm work with Marcel on CUE. My name's Roger Pepe. I've worked on a few things in the past, but nothing quite like this. I actually encountered CUE sometime before I started working for Marcel, and I found it really useful. Marcel gave a talk, and I was really intrigued by how you could use this thing in a bunch of ways. I was writing YAML files, but I had no way of saying whether those YAML files were actually correct in any way before I actually produced them, gave them to the program to actually run. And this is a way that I could do that really easily. So I'll kind of demo some of that. This is going to be, pretty nuts and bolts. So I'm just going to show in a very bare bones way how you can use CUE to validate some non-CUE data files. So this is a classic example where you might have some existing YAML or JSON and you want to write some constraints, so you want to check that they actually correspond before you actually give it to the program to run. So in this case, I'm going to use a Docker Compose file because that's something that hopefully most... Hello? That most people might be familiar with. And then I'm going to show how we can actually take some schemas from our central CUE registry to do a better job of that checking. And then we'll see how far we get with this, because I haven't actually run through this, so we'll see how far we actually get. But the aim is to abstract this into a reusable component, publish that to registry, and then use CUE to perhaps generate the configuration. So this is the file that we start with, and this might be familiar to most. I'm just got a couple of a very simple compose thing, which has a very simple web service taken from the Nginx demo, and a database that isn't used by anything, but nonetheless, seems like, in fact, that looks dodgy, doesn't it? Because I've got the DB indented, but that's YAML for you, right? So let's switch to demo mode and a different microphone. Thank you. And I'm going to use my weird editor that you probably... Anyway, so here's the Docker Compose file. And so now we're going to say we actually want to care... Like the scenario here is that I'm some company, let's call it Splot, and everyone in our company is responsible for producing a web service, and to test our web services, everyone is going to be producing a Docker Compose file that we want to have, that everyone has to produce something. It has to have a web entry in the services, and it has to expose something on port 8080. So we'll write a CUE schema. Here we are. Well, we'll start off. We've got a package name. And okay, so let's say we've got let's call it web service. And we care that we've got a services field, and that exclamation mark means the field must exist. If the field doesn't exist, then our validation will fail. And it's just like JSON really, except, I mean, it is actually a superset of JSON. CUE is a superset of JSON. And we're saying the web service must exist, and maybe let's just leave it here. And the ... mean we can have any number of other fields in there, because the hash on the web service means a definition. And definitions are conventionally used for schema, and they're closed. So if we say anything that's not there, then we'll have an error. So let's say let's go to, oops. All right. Okay, let's try that, shall we? CUE vet. So CUE vet is for checking. We're going to vet, and we're going to use, that's the schema. And we're going to run schema.q against docker compose.yaml. Oh, it says it's, it's done nothing. Is that actually the case? Right, well, let's try, maybe we spelt web wrongly. Okay. Let's try it again. Okay, it's telling us that something's wrong. So it's actually doing some work here. So we've actually got something useful here. We can run this against our Docker Compose file, and it will tell us some properties that we care about. So in this case, perhaps we actually care, we care that ports has a single entry in it which matches, that equals tilde is a regular expression match operator, hat 80 colon. Okay, so that will, oops, a bit shaky here. Okay, so we can actually know that is also required. And we can run it again, and we haven't changed that back. And still not allowed. Okay. Well, we didn't open that up. Okay, that works, and we can just check. Say we named that wrongly. We can also see that. Oh, okay, it's out of band. It's telling us what went wrong. So okay. So okay, this is a start, but actually a Docker Compose file, we can put a lot in there. We can actually do a lot of checks that we are not doing here. So and writing out the entire policy, the entire schema for a Docker Compose file is quite a job. But luckily, we already have such a schema published to the central registry. This is all new stuff, so currently the path is at a temporary place, which is not the most obvious place, but I've got copy and paste here. Here we are. We call it Docker Compose, and we can say compose.schema. That's where it's published. And that ampersand operator is a unique thing to CUE. That's the unification operator. And that says these two things, both these things are true together. And CUE does, the U in CUE stands for unification. And this unifies those two facts together to make one thing that is more specific, both at the same time. And if there's any incompatibility between them, then it'll tell you immediately. Okay, so we've got that schema there, but if we run that now, it won't. No, there's no CUE module file. Okay, so we need a module file. So we're gonna let's call it splot policy. All right, that's a random name. That's under my GitHub name, so that potentially we can publish it later. We'll see. And we're going to do. I think we need to do CUE login here if we're going to talk to the central registry. So we just tell us open link. Oh, okay. we've authorized that usually would take me through the GitHub login process, but I've logged in. Basically, at the moment we're using GitHub as a proxy for our authentication to the central registry. So it doesn't ask for any permissions. All it asks is basically who you are. Okay, so if we do that again now, it can't find the package. That's because we haven't got our dependencies yet. So we can say CUE mod tidy. If you've ever used Go, this is like Go mod tidy. And that goes away and thinks about things. Oh, that worked. So if we look at this thing now, we've got a CUE.mod file with a module.q file here, and it tells us what our dependencies are. And it says this is exactly this version of this module, and that will never change, right? That will always be valid for the future. Even if we move to a different name, this version will still be around. It will be compatible. We can upgrade versions, but this is stable now. So if so now we can actually see that if we change our file to add something that we didn't constrain before, but say we change this to a Boolean or something that is not a string, then perhaps it might tell us, okay, right, now it's telling us that there's conflicting values between true and string. So it's actually checking the entire Docker, the compose spec here. We actually imported that schema from the JSON schema version from Docker Compose spec because there's actually reasonably good support for converting JSON schema to CUE. So we've got that's a good start, and you can imagine that there's for any YAML that you have, you could hopefully imagine how you might apply this to your own sort of situation. But this is only sort of half of CUE's capabilities. It can check schemas, but also it can generate actual data. So let's try and do that now. So we've got this schema.q file. Let's say we'll make another thing, let's actually make it. In fact, let's try and import the Docker Compose file to CUE. All right, so we'll do that. We'll do CUE import, and we'll try and put it into okay, so we're going to CUE import package splot policy, same package, and like Go, you can have any number of files in a directory, and they all part of the same package. And we're going to put it into path name content, and we're going to import Docker, the actual YAML file. Okay, we can have a look at that now and see how that the YAML file now is CUE. So this is what that YAML file looks like as CUE. We've actually got some redundant braces here, which means that indentation is no longer significant, which is good as far as I'm concerned. So if we can actually, if we want to export that, if we do export, maybe we want to export it as YAML. CUE export minus out YAML, and we'll give it an expression. And there we see the original thing back as YAML. So you can see we can go back from YAML to CUE and back again. So in this case, we might want to, okay, well, actually, clearly this is wrong, right? But that's because we haven't actually linked it up with our schema. So here, you can see the capability of CUE to do two things at the same time. We'll say that content is schema, and at the same time, it's also this. So let's try exporting it. Oh no! What did we call it? We call it web service. I can get the. Okay, and now we see we get the we've actually linked those two things together, and we know that we can actually set the image to something like docker.o / whatever it was, nginx, wasn't it? Somebody remind me what it was. How are we doing for time? 5 minutes. All right, we might not end up with doing everything. Let's see how it goes. All right, so we'll put that back. That should work. All right, so I'm going to skip a little bit here, but I'm going to try and publish to a registry. I'm actually going to publish to a local registry because I don't want to publish it local. I don't want to publish to the central registry, but we can do that. There's no problem with doing that. This is a very distributed system. These are just OCI registries, but actually I have there's a command called CUE registry, which actually it just runs a local in-memory OCI registry. It's just easier than running whatever alternative there is. So let's try something like that, not 65. All right, so that's now running on the registry. And if we want to publish to that, we can actually use both registries at the same time. So we can say export CUE registry, and we'll say for anything from github.com/rojpepe, then we're going to take it equals localhost : 64324 64324 64324. All right. And anything else is going to go to the central registry. So now we'll try CUE mod publish v001. See whether this worked. We need the source field. Source : kind : self. We're just saying we're not coming from anything apart from Git from ourselves. It's just self-publishing. Let's try again. Okay, now we've published. So we've actually published. Now we've published to the central registry, to our local registry, but that is also talking to the two things are talking to this. We kind of got a fork. Both registries at the same time, if you like. If we wanted to publish to the central registry, then maybe we could do. I've never tried this before. Maybe I won't try this. Let's not try this. So the point is that what we've done there is publish to a place where other people in our organization can read from, can be reused. It can be published to a specific any registry of your choice, or the central registry if you want to make it available in public, and that's should be useful for all kinds of things. And there's a bunch of curated schemas we've published already, and hopefully lots of people will publish other reusable templates, schemas, and all kinds of other things.
Not yet. Can you put back the... Yeah. Yeah, we're going to start. Huh?
Oh, yeah.
Where's the? Yeah. So here you see what we have so far. Like Roger demonstrated that. There's a few things that will be future work to do. So especially with the curated schemas. So if you, for example, go from JSON schema to CUE, you will the JSON schema can have versions also, right? Like they put it in the path or whatever. But there isn't really like a standard or some consistency. So we have we're still sort of looking at how to map that to CUE. It will probably not be a one-to-one mapping for sure, but whether to map at least minor or patch or just everything to minor. Is sort of up for grabs, but what we at least want to do is be able to label the CUE versions with the original versions, right? So that at least there is with tooling you can track the original version. So then there's cases, so MVS is great, right? Like you have this stability, it's reproducible, but in some cases, so there are cases in configuration where you really don't want that. You want to be more aggressive with moving the versions forward. So one example, for example, is policy. So if you have, you know, like a policy aspect, then you want the latest update because, you know, otherwise you might not be complying to legal requirements or whatever. So this is not something that will be a feature of this, I think, because you can easily solve that with tooling. But, you know, it's something to keep in mind. So another one that we will have to address is the opposite problem. So this is very different where really configuration starts to differ from software. So it's much more common in configuration to really need multiple versions of the same major version within one configuration. So you can have, for example, that one configuration needs to talk or address two separate systems which are really the same but have different versions. And if you want to very accurately check that, you need both of these versions at the same time. So luckily that's not really a problem in principle. We have looked at how would MVS work in these cases, and it's a solvable problem. Just haven't implemented it yet, but that is one of the next things on the roadmap for the central registry and version resolution. This is a much requested feature. So then a little bit about the community. So we have many users. This is just a small sample. This is our team, 6 people. If you have any questions, feel free to contact any of us. So we have also this Wednesday, there's a workshop, so where we can like walk you through in a bit more detail how to use the central registry, or if you have any other questions about CUE or how to do things, how to organize things, because it's not always maybe so obvious. It's quite a different approach. You're all welcome to attend. So that's it.